Hello friends, this is a 2-mark question on DMGT and topic graph theory. The question reads as follows. Consider the following graph. Which of the following is isomorphic to the given above graph? We say that a graph G is isomorphic with graph H if there is a one-to-one correspondence between vertex sets of G and H such that any two vertices U and V of G are adjacent in G if and only if f of U and f of V are adjacent in H. This definition implies that the number of vertices, edges and connected components in graph G and H will be same. So let us check which of the given option has same number of vertices, edges and connected components as the original graph. The original graph has two connected components and all the options given here also has two connected components. Also, the number of vertices in the first connected component is 8 and second connected component is 5 in the given graph, and this is same for all the options given in the equation. Now let us examine the number of edges. The first connected component has 16 edges, whereas the second connected component has 8 edges in the original graph. Out of the given options, only option A and option C has same number of edges for these two connected components. For option B and option D, the number of edges in the first connected component is 18, which is not equal to the number of edges in the first connected component of the original graph. So option B and option D are wrong. Graph isomorphism also implies that the degree of corresponding vertices in both graphs should be same. For the sake of understanding, let us label the original graph G. We have the first connected component in the original graph G has degree 4 for each of its vertices, whereas the degree of vertex I and L in the second connected component is 4 and the other three vertices has a degree of 3. So let us check if the corresponding vertices in option A and option C has same degree as the vertices in the original graph. Let us first label the graph in option A. We have the second connected component in option A is same as the second connected component of the original graph. So the degree of vertices would be matching. In the first connected component of option A, we have degree of vertex 1 and 4 as 3 and degree of vertex 5 and 8 is 5, whereas all other 4 vertices has degree of 4. Thus, the degrees of these two graphs are not matching, since all vertices in the first connected component of the original graph has degree 4, whereas the vertices in the first connected component of option A has degree of 3, 4 or 5. So option A is also wrong. So the correct answer to this question is option C, where we have following mappings between vertices. That is, vertex A till H in the original graph are mapped to vertex 1 to 8 in the first connected component of the graph option C, and vertex I in the original graph is mapped to vertex 10 in the graph C. Similarly, vertex J is mapped with vertex 9. Vertex K is mapped to vertex 13 vertex L is mapped to vertex 12 and vertex M is mapped to vertex 11 in the option C. And now if we check the degree of each corresponding vertex in graph C and the original graph, it would be same. So these two graphs would be isomorphic. So the correct answer to this question is option C. Thank you.